Hi everyone, thank you so much for coming to this lesson. So we're going to be talking about functions, and the learning objective is to be able to understand and apply functions, including inverse and composite functions. So like always, there's going to be timestamps in the description, so feel free to skip to any part you would like to. So let's get started. Firstly, you just need to understand the definitions of functions and the different definitions you need when describing functions. The first one is just the definition of what a function is. The function is just any operation that takes numbers and maps each one to only one number. So one example of a function is fx is equal to x squared. So if you draw this on a graph, you have fx equal to x squared. You see that if you have 1, that maps onto 1 as well, and if you have 2, that maps onto 4. So for all these numbers, this maps onto another number. And similarly, if you have g of x, which is equal to x, which is another function, you can see that for every number you have, you get another output. So these are two examples of functions. And the domain is the set of starting numbers. So you can think of it as like the set of inputs you're putting into the function. So for this fx equals x squared, you could say the domain is the set of real numbers, the set of all numbers on the x-axis that you can input into the function to get an output. And the range is just the numbers the domain becomes. So it's like the output. So in this example, the domain would be 1, 2, 3, 4, and then the range would be 1, 4, 9, etc. And a one-to-one function is one that maps one element in the domain to another in the range. So g of x equals x, that's an example of a one-to-one function, because for every number that you input, for every domain, you only have one range that corresponds to it. But in comparison, a many-to-one function is one that maps more than one element in the domain to one in the range. So if you have fx is equal to x squared, you see that for every element in the range, 1, you have two different numbers that in the domain that it corresponds to, as -1 and 1, they both lead to 1. So this is not a one-to-one function. You would call it a many-to-one function. For this one, because there's only one element in the domain corresponds to only one element in the range, and vice versa. So this one's a one-to-one function. And also you have one-to-many functions, and these map one element in the domain to more than one in the range. So if you have a function that for every one you input, you could get like 5 and 6, then this function that would happen, that would be called a one-to-many function. That's just an overview of functions, and now we can go into some applications, including how we can use composite functions. So moving on to composite functions are just a combination of two functions. So let's say you wanted to try and figure out what g of gfx is. The way you would do, so that is an example of a composite function. What you would do is you would just do what f of x is first, and then you would do the g of, and then you would input what you got from fx into g. That makes sense. The order really matters. So if you switch this around to do f g of x, then you would do f of g of x. So you would do g of x first, and then you'd input whatever you got on there into f, and you do f of whatever value you got. And if you have f of x, that means you just do it twice. So you do f of x first, and then you do f of whatever that value was. So if you do an example of this, let's say you have f of x is equal to 2x cubed, and g of x is equal to x minus 3. And let's say we wanted to figure out what f of g of x was. And we want to figure out f of g, if we have a specified x value, let's say we want to do 4, what you do is you'd first do g of 4. So that's equal to 4 minus 3, which is just 1. And then you would just do f of 1. So that's just 2, 1 cubed, which is just 2. So if you guys try, why don't you guys try to do what f of 10 would be? So try pause the video and do it yourself and then come back to the solution. So f of 10, you just first do f of 10, and that would be equal to 2 and then 10 cubed. So that would just be 2,000. And then if you do f of, then you'd input that again, so you do f of 2,000, that would just be equal to 2, you'd get a really, really big number. So yeah, you can just input that into your calculator. So you'd probably get 16, you would just get something really big. So 2 times 2 to the power of 2003. So you can find the exact value in your calculator. But yeah, that's just the gist of what composite functions are. And you might be asked to apply these when you're solving like an equation. So we'll move on to an exam style question of this next. So we have this question here. We have fx is equal to x squared minus 3. We have g of x is equal to 1 over x. Now you want to try and solve what gf of x equals 1/6 was. So you really need to try and find what the value of x is specified as this equation. So try this question out yourself. So pause the video and then come back. So the way you do this is you would first just want to find an expression for what g f of x would be. So you do f of, so you just do g, you know f of x is just x squared minus 3. So you just do g of that, so you just do g of x squared minus 3. So you just sub in x squared minus 3 into this equation. That would just be 1 over x squared minus 3. And you want that to equal 1 over 6. So now you just want to try and solve this. So you'd have 6 is equal to x squared minus 3. And if you try get everything on, and then if you add 3, you'd get 9 is equal to x squared. Then x would just be equal to plus or minus 3. And that would be your answer. So moving on to inverse functions. So an inverse function is basically just the opposite of a normal function. So the notation for an inverse function would just be f to the power of minus 1 and then f of x. So an inverse function is one that you switch the domain and range around. So it's one that matches every number in the range to a number in the domain. And it has a special property that if you do f of minus x, if you do, you would just get that is just equal to that's just equal to the other way around. So it doesn't matter. The order doesn't actually matter for this one round. And you just remember that when you're trying to draw the inverse, that is just the reflection of that graph in the line y is equal to x. So let's say you had an equation that, let's say you had a graph that looked like this, and you wanted to find the inverse of the function, you just reflect it in the line y equals x to get it so it looks something like that. And when you're doing the inverse function, all the numbers in the domain, that would switch to being all the numbers in the range of your inverse function, and then all the numbers that you had in the range of your f of x, that would switch to becoming in the domain of your inverse function. So moving on to how to actually work out what the inverse function. So let's say you have this function f of x is equal to 3x squared plus 2. The way you'd work out the inverse function is this is quite like standard process you would do for any, so just try and remember all the steps. The first step is you just replace f of x at y. So you just do y is equal to 3x squared plus 2. And then you'd rearrange this to have x on one side. If you do y minus 2 is equal to 3x squared, then divide everything by 3, so you'd get y over 2 is equal to, over 3 is equal to x squared. Then you would have plus or minus root y over 2 over 3 is equal to x. Then you just replace x with the inverse. So what I forgot to state was what the domain of this function was. The domain is just values of x which are larger, greater than 0. So that's the domain. So because x has to be larger or greater than 0, you don't need the negative sign because it has to be positive. So you could just do that. So the inverse is just the square root of y minus 2 over 3. And then you can just substitute the value of y as x. So you'd get f. You just get f inverse x is just equal to square root of x minus 2 over 3. And then if you want to state the domain and range, you know that if the domain for f of x is greater than or equal to 0, your range for this would now be f of x so the range of fx would just be fx is greater than or equal to 0, just for the inverse of fx, sorry. And then you need to work out what your range would be. So for this, what would the range of f of x be? So if all the values of x have to be greater than or equal to 0, so you have the smallest value of fx that you'd get would just be if x is 0, so it would just be 2. And then as you increase values for x, your range would increase. So then the range of fx is just fx, values of fx, which are greater than or equal to 0. So that means that the domain of f of the inverse of fx is just values of x that are greater than or equal to 0. So that's how you find the inverse of a function and how you find the range and the domain function. So let's move on to trying an exam style question. So we have a question here. It says the function f is defined by f 4 minus ln x plus 2, and we need to try find the inverse of it and the domain of the inverse. So pause this video now and try this question for yourself, and then come back to the solution. So if you remember what we did in the last example, we just need to follow those same steps to find the inverse. So we rewrite. So if we have f of x is equal to 4 minus ln x plus 2, so the first step is just to rewrite f of x as y. So you get y equals 4 minus ln x plus 2. And then we want to rearrange to just get x on one side. So we could bring ln x plus 2 on this side, and then we could do 4 minus y. And then we could we need to try and switch this ln x plus 2. We need to try to get rid of this. So to do this, we raise we do e to the power of 4 minus y. So if you've forgotten how to manipulate ln and exponential functions, go back to that video. So it'll be e to the power of 4 minus y. And then you just do x is equal to e to the power of 4 minus y minus 2. And then you just say that x is now, you rewrite that as the inverse of x, and then you substitute y as x, so it would be e to the power of 4 minus x minus 2. So that is how you write the inverse of x. So yeah, if you've forgotten how to do this manipulation with the linen E, so then just go back to that video and make sure you've fully understood that. For part B, remember that the domain of an inverse is just the same as the range of just f of x. So if we know that the domain of f of x is values of x are greater than or equal to -1, then you can use that to try and solve the range. So if we plug in the lowest of the range, f equals to -1 is the function. If we do f of -1, that's equal to 4 minus ln -1 plus 2, which is just 4 minus ln 0. So if you remember, ln 1, if you remember ln 1 is just 0, so this would defeat to 4. And then to see what would happen to these numbers as x becomes greater than -1, you can kind of think of the graph. So if you remember, the graph of ln of x is just something like this. So you know that as the values of x increase, it's not exactly the same, but so if you don't remember the ln graph and go back to this. So if you know that the values of x increase, then the value of ln x would also increase. Then you're going to be subtracting a larger value of 4 each time. So then your output would decrease as you increase x. So just remember that ln x plus 2, that's just a transformation of this graph like by 2 in the left-hand direction. So it actually goes like this, ln x minus 2. But yeah, if you've forgotten transformations, go back to that video. But it's not the end of the world if you don't know it for now. So just know that as the values of x increase, the value of ln x plus 2 would also increase. So then you're subtracting a larger and larger value from 4 as you increase. So this value would decrease as you increase. So therefore, your range for f of x would just be values of x, f of x less than or equal to 4. So that means your domain for inverse of fx is just values of x which are less than or equal to 4. So yeah, thank you so much for listening to this video. Hopefully it was useful. So just to sum up, we learned about functions and how to do the inverse function, and also using equations that involve the composite functions. So make sure you do some practice questions, just to make sure you fully understood everything. But yeah, thank you so much.